This lesson will be focusing on finding a raw score when we work with normal distributions. Calcium levels in people are normally distributed with a mean of 9.3 milligrams per deciliter and a standard deviation of 0.3 milligrams per deciliter. Individuals with calcium level in the bottom 5% of the population are considered to have low calcium levels. Find the calcium level that is the borderline between low calcium levels and those not considered low. Carry your intermediate computations to at least 4 decimal places. Round your answer to 1 decimal place. Because I am told that calcium levels are normally distributed, I'm going to use the normal curve. It is centered at 9.3, which is mean, and I know the standard deviation of 0.3. I'm told that the bottom 5% is where calcium levels are considered to be unhealthy. And of course, the top 95% is where calcium levels vary, but they're all considered to be within the norm. We need to find this boundary quantity that separates the unhealthy calcium levels from healthy calcium levels. Because I have the area to the left available to me and I need to find the corresponding C value, I'm applying inverse norm to the area to the left side of C of 5%, mean of 9.3, standard deviation of 0.3, and of course, please remember that inverse norm works when you consider area to the left of your unknown value C. This results in 8.8 milligrams per deciliter as this boundary quantity, which is going to tell you anything below is unhealthy, anything above is considered to be healthy. One more example. Suppose that scores on a particular test are normally distributed with a mean of 120 and a standard deviation of 15. What is the minimum score needed to be in the top 5% of the scores on the test? Carry your intermediate computations to at least 4 decimal places and round your answer to 1 decimal place. Just like before, let's get the diagram. Based on the fact that the scores are normally distributed, I use the bell-shaped curve, which will be centered at the mean of 120. And I am interested in the top 5%, and I want to know which test score separates the top 5% from the remaining 95% of scores. I want this value of C that has 95% of data to the left of it. An inverse norm uses area to the left of the unknown value C. So C is equal to inverse norm of 95% of area, 120 is the mean, 15 is standard deviation, and I am reminding myself again that area must be to the left of C. This results in 144.7 as this boundary score that separates the top 5% from the remaining 95% of scores.